York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio.
Good evening, everybody. Welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, not to mention the darn good friends of York University. I'll be one of your two hosts this evening. My name is Paul Delaney, and I'm joined by the director of the Allan Carswell Observatory. Hi, Elena.
Well, hello. It's wonderful to be here. Previous director of the Allan Carswell Observatory. We've got
it cornered, haven't we? Monopoly on the observatory.
Yeah, we absolutely have Australian directorship of the of the observatory locked down. So we're happy to be here. I have, of course, been training myself to get up at 5 a.m. to meet with all the electronics people for our new domes and all that kind of great stuff. So it's been a really interesting week, and I'm just glad to be here. At what time is it now? 9 p.m.?
That's right. It's York Universe. It's got to be 9 o'clock. Hold that thought. We'll talk about the antics of the last week in just a second. We are broadcasting live, if anybody hadn't figured that out, from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. And tonight, it's Monday night. It's therefore Science Night in Canada, where the lineup is more or less entirely Canadian, starting with ourselves, York Universe, on to Western Worlds. I think they're still in place. Quirks and Quarks, not to mention Science for the People. We are, of course, broadcasting every Monday evening, 9 p.m. local time. That, of course, at this time of the year works out to be 1 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team. Hi there, guys. It runs, not surprisingly, between the hours of 9 and 10 o'clock here, Toronto local time. By all means, point your favorite web browser to observatory.info.yorku.ca and follow the links to OPV, online public viewing. And, of course, join the chat room there. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you might have about our past shows, or if you have suggestions for future topics, by all means, drop us a line, an email, observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @YorkObservatory. And, of course, Facebook is @Allan Carswell Obs. All of our programming is free, but if you would like to make a donation, by all means, visit the website, observatory.info.yorku.ca, and look for that big, friendly donate button. We'll be monitoring the chat room for questions, probably posting content there too, in between our chitting and our chatting this evening. So, you're back to a regular schedule now, Elena?
Oh, not quite. I've I can tell you that automatic forms are not good for everything, which is why we still have an email. So hooray for the observatory.
All right, we'll stick with good old 20th century technology. Fair enough. All right, well, we've got all sorts of things to cover this evening, not to mention our serenade to the summer, which will happen tomorrow morning, but we'll get to that in just a few minutes. Let me lead us off, take us all the way back to the 18th century. Yes, we're going back a little bit.
Hooray!
This is a happy birthday shout-out, and hi to Shatish, but this is a happy birthday shout-out to Charles Messier, born June 26, 1730, so that's nearly 300 years ago. As I said, June 26, he passed away April 12, 1817. So that was a pretty good lifetime for that era in history. I always think of Charles as a bit of a frustrated comet hunter, and I'll tell you why in just a moment. He was French. That has nothing to do with the frustration, but he did all of his observing from the French countryside. The 1700s obviously secondly, the sky quality was simply excellent at that point in time. You weren't being terribly distracted by other things, no computing, no cell phones, and so on. So he had the opportunity for lots and lots of wonderful observing. And observe he did. He was definitely one of the most prolific observers. His instrument of choice, believe it or not, was a 4-inch refractor. Now, that sounds pretty tiny, but remember, it's barely a century since the dawn of the telescope and its first use by Galileo in 1610-ish, more or less. So barely a century later, refracting telescopes had not advanced terribly in terms of diameter, casting those objective lenses to the quality needed for good resolving power was not easy. But nonetheless, it was, as I said, a 4-inch, which is 10-centimeter refracting telescope. But good quality skies allowed Messier and his colleagues, and I do have a shout out here to Pierre Machin, who was one of his long-term observing partners. Together, they would roam the skies looking for comets. And of course, that's something we still do to this day. The problem was they kept coming across things that were obviously not single stars, but equally, they were not comets. Hence my commentary about him being a frustrated observer, because here he is trying to find comet after comet, and there are literally dozens, in fact, nearly 100 false alarms throughout the course of his observing career. So he stopped observing comets for a while and started cataloging these non-stellar objects, these things that were obviously not comets, but equally they were not single stars. And of course, we're talking about star clusters and nebulae primarily. The term galaxy did not exist at this moment in history. So there were a lot of objects that he observed that we now know, of course, were galaxies, but they were just classified as nebulae and non-stellar objects. This is the famous Messier catalogue. There are 110 such Messier catalogue objects, although interestingly, not all of them were found by Charles Messier, and even the ones that he is given the rightful claim of, yes, he found this, there's a bit of debate about whether or not he found it or whether or not Pierre Machin found it. But between the two of them, there was no animosity as far as I can tell. They certainly found their share of the Messier catalogue objects, but interestingly enough, not all of them. The 110 Messier catalogue objects are the staples, if you will, for both amateur and professional observers. We've taken many, many, many images of Messier objects over the years with all of our differing telescopes at the Allan Carswell Observatory, and obviously they are stunning when you can build up enough photons, so you take many, many exposures and you stack them, and away you go. They are just wonderful, and amateur astronomers do exactly the same. These objects date all the way back, as I said, to the 18th century and the efforts of Charles Messier and his colleague Pierre Machin. Interestingly enough, though, I said at the beginning that he was a bit of a frustrated comet hunter. Well, I am pleased to report that he did in fact find 13 comets throughout his career. Not shabby at all, although again I say it wasn't just he who found them. At least one or two of them it certainly is likely that Pierre Machin was a significant contributor to the observations for those comets. But when you think about it, all through the 18th century, 110 odd Messier objects and 13 comets, pretty good observing career with a 4-inch telescope, don't you think, Elena?
Oh, absolutely. And if you actually look, a lot of times you'll see people saying, what can I see with a small telescope? What kind of targets would I be able to find if it's just a small little 4-inch refractor? Well, they might look kind of like blurry blobs, but 110 awesome objects await anyone looking to make a search. And even if it is still a 4-inch telescope, if you can get dark skies, the telescope technology in the meantime has improved. So you might get a little bit of dark skies, you might get a little bit of a better view than Messier had.
Absolutely. The purview of the small telescope should never be understated. To me, a small little telescope, selecting the right objects, gives a great deal of satisfaction. Sure, 4 inches is not very large diameter, and therefore the images could be a little on the faint side. hence Elena's commentary about, dark skies. If you've got good contrast, then a 4-inch telescope is going to do a wonderful job, especially on things like globular clusters, open clusters, and so on. You might struggle a little bit with the detail of galaxies, but my gosh, you will still be able to find many fine galaxies that will be well revealed by a 4-inch telescope. So yeah, small telescopes, not to be sneezed at. They're easy on the pocketbook, very portable. There's lots to be said. Just don't try and ramp up the magnification. There's a bit of a tendency to try and stuff that 4mm eyepiece in there to give yourself a gazillion times magnification, whatever, and that's not cool. Even at the observatory here, very rarely do we put in an eyepiece that is under about 25-30 millimeters. That gives us ample magnification to show almost anything we want, and that includes with our 40-centimeter telescope. You just don't need a lot of magnification generally to have a really satisfying view.
Well, a lot of times the view will actually be better with the lower magnification. And it's interesting you mentioned eyepieces, because one of the big improvements, I would think, since Messier's time would be, of course, modern eyepieces with all of these adjustable different fields of view and magnification.
Quite correct. You can actually get lost in the forest of eyepieces. If you walk into a telescope store and say, I want to buy an eyepiece, a lot of them roll their eyes at you because, they've got 1,000 on the shelf. What do you want? Is it wide field? What is the magnification? Do you want it to be multi-element? And so on. Magnification is certainly not the be-all to end-all, and modern eyepiece technology certainly is wonderful. The field of view, the eye relief, a good eyepiece really makes a good telescope. If there's one takeaway message, when you buy a telescope, if you're buying sort of something like, say a 20-centimeter telescope, something of that ilk, it's going to set you back $1,000, maybe more, $1,000, maybe more. There's no point buying a $25 eyepiece. That eyepiece is now cheapening your entire investment. So buy a decent eyepiece. Go out and spend the $100, $150, because that is what will take full advantage of your $1,000 investment from the telescope. So yeah, splurge a little, people. Don't go for the cheapest eyepiece out there.
Well, unless you've only got the 4-inch telescope, in which case you've probably only spent about $150.
Yeah, well, that's exactly right. Maybe we should go with sort of a ratio of sort of 5 to 1. If you buy a $1,000 telescope, you can spend up to $200 on your eyepiece. If you spend $100 on your telescope, you can spend about $20 on your eyepiece.
It's sort of like cars and tires. You wouldn't want to. Yeah. I guess. I haven't ever bought an expensive car, so I don't know. But
nor have I, although no car is cheap. Anyway, we digress.
All right.
You want to take us back in history, I believe.
Yeah, so I'm going up from the 1730s, but not that far into the future or past. We actually want to travel to 1967, and this actually gets me to that little spoiler I couldn't resist chatting with Paul about earlier, because in 1967 in Toronto at York University, the ash domes went up onto the observatory at York. And I believe it was around this time of year. So I'm calling it a This Week in Space Astronomy History fun fact, because it is absolutely amazing to realize that the original domes that we replaced last week, they had been there since 1967. The Petrie Science and Engineering Building hadn't even finished being built when the domes were put on top. And you can tell this because in the York University Library archives, there are very old pictures, and there's one from 1967 with the Petrie building under construction, and the domes are already on top. And those are ash domes, and it's actually the same manufacturer that we got our domes from this time, but they've had many years to improve them. And so I just had to put that up as our fun fact of the I suppose, fun fact of this week in space and astronomy history, because of course, when the domes first went up, it was primarily with the idea that it would be a research endeavor, and the dark, dark skies around York, where there was in 1967 no football field and not very many buildings around either. So that was, 55 years ago.
That's right.
Whole area would have been tremendously different. They were working on the Petrian Science and Engineering building, but you can see in the pictures, there's nothing else nearby. It's just open fields.
It's very true. One of the most famous images in the York archives is the founding president, Ian MacDonald, sitting at a desk in the middle of a field.
Excellent.
Literally. Yeah. It really sums it up. York at that point in time was on the almost on the frontier of southern Ontario. Toronto itself was still many, many kilometers to the south, and there was essentially nothing to the north of us. All of the suburbs that surround us now by many kilometers, none of them had reached York at that point in time, which of course, just going a little further afield, just north of us is the David Dunlop Observatory that was founded some 30 odd years earlier, and it was even more in the middle of nowhere. That's why the University of Toronto, courtesy of the bequest of David Dunlop, put their observatory with a 1.8 meter telescope, quote, so far north, end of quote. Well, of course, we now know, sadly, that civilization has overrun the David Dunlop Observatory and now goes many kilometers further north of that facility. So over the last, 50 to 80 years, it is really quite stunning to see the progress, I'll use that term carefully, that Toronto has made as it has charged north.
Yeah, the suburbs have eaten the telescopes, unfortunately.
Yes, they have.
But of course, we will say that, we do still have the capability to do some research projects, and when they turn the stadium lights off at York University, we actually can get down to magnitude 20, so it's quite good. And of course, with programmable domes, the big new adventure, which is ongoing. So if you are looking to come up and see the new domes, please give us 1 or 2 more weeks to finish the electrical hookups.
Yes, it's a non-trivial exercise to take 2 domes off and put 2 new domes on and try and connect up to state-of-the-art telescopes. This is a non-trivial exercise.
Well, and I will say the actual placement did go fabulously well, as I'm sure most folks have heard by now. But on the 14th, when we went to place the actual new domes on top of the building and take the old ones off, there wasn't so much as a gust of wind. Of course, we were all up at 5 o'clock in the morning, but that's how you do these kinds of things. And I imagine that they probably put up the original domes in 1967 in a very similar way. They must have had some sort of crane to lift the original ash domes up on top of the building, and they would have had to construct the domes on site or ship them, I suppose, from the US, but usually they would be constructed on site. Mm-hmm. So I imagine that, we actually sort of had a little bit of repeat all the way from 1967 last week. It's sort of repeat but updated.
Who said history doesn't repeat? Yes.
Yeah, no, repeating with updates is just exactly my...
Absolutely. I'm just glad Ash is still in business. I mean, 3 cheers for them. There's a lot of organizations that don't necessarily make 50 years and counting, yet in this particular instance, we were fortunate enough that the original manufacturers have remained in business and, of course, are still producing that size dome. That made life so much easier for us when you think about it, Elena. If we'd had to reconstruct the concrete foot upon which the domes were going to sit, that would have immensely complicated our lives, not to mention our budget.
Exactly. Well, and we did have the footprint of the concrete ring that the dome has to sit on. It does have a little bit of a width to it, so we could get away with a small difference in size. But it was just amazing because these domes, they're made by the same company with all of these amazing improvements, and they're literally the exact same width or diameter. They
Mm.
are actually higher. They're a little bit different in height, but the diameter is exactly the same. So they set down right on top of the previous footprint, which
It
meant that
was
all the
poetry in motion.
oh
Poetry
yeah,
in motion.
poetry. Well, it was mechanical engineering precision, which is maybe even better.
That's right. And let's add that extra little touch, seeing we're talking about precision. These two domes have drop out rather than drop
Yes.
down shutters. So, of course, one of the things that I'm sure you and I both dreamt nightmarishly about was the calculation that when both domes had their drop outs extended,
Yep.
would they actually touch? And of course, the answer is no.
No.
Yeah, we measured it probably 13 times, if not more, in the last year. But until you actually opened up both domes and spun them around to see whether or not they would touch, I, for one, I'm free to admit this, I, for one, was so delighted to see that 9-inch gap.
Yes. Well, and originally when we did the calculations and we checked, we thought it would be 7 inches. And so we actually gave ourselves an extra 2 inches, I guess, on the placement, but it was absolutely perfect. And they've all spun around. We have a nice picture showing the gap. Of course, with a drop out shutter, you really don't want to be on the roof while they're spinning around. But
No, that's one big difference.
we don't let people up there anyway, so don't
No.
worry, folks. There are no roof tours at the observatory, totally off limits.
And all
But
of our observatory staff are accounted for every week of the year.
yes, yes, absolutely. No missing astronomers. And the clearance on the side railings was actually quite good as well. I believe that was it 11 or 17?
I think it was 17. Yeah.
17, yeah, 17 inches clearance on the railings. So there's nothing it can collide with, and the drop out is actually on hydraulic
Rams.
hydraulic
Well,
pistons, rams, if you will, and those are mechanically blocked. So there is no physical way for them to drop any lower.
yep.
Which is excellent, excellent. So
It's
there's
gorgeous.
and it, of course, it moves like a dream. You can actually hear yourself talk while it's moving around, and it will be able to follow the telescope, and it doesn't leak, which is all in all fabulous.
And when we get back to in-person public viewing, and as you've indicated, it's still several weeks away. In fact, I think people should think August probably, but we'll keep you informed in that regard. People will really be impressed with the telescope and now the dome and the way the two play together. It will be a real treat for those who want to come up and observe.
Absolutely, and just come up to see things and have a nice tour. Looking forward to that very, very much.
All right, I'm going to take us to one of the objects that you will be looking at in August because it is rising around about midnight at the moment and therefore cruising into the evening sky. And I'm referring to the planet Saturn. It picked up a it wasn't a natural. It picked up an artificial satellite back in the day in 2004. And I'm referring to the Cassini spacecraft. Well, Cassini slipped by Venus on one of its multiple gravity assists back on June 24th, 1999. Cassini, of course, was launched 2 years prior to that, October 15th in 1997. Its destination was Saturn. And, of course, Cassini had a hitchhiker on board with it, the Huygens probe from the European Space Agency. So this was really quite the international mission. To get to Saturn, it's a little further out, and it required a little more oomph to get there. Cassini flew by Venus, Earth, and Jupiter to pick up 4 gravity assists. So basically, we shot it towards the inner solar system, picked up a little bit of energy and thus speed from Venus, flipped it out, grabbed a little more energy and speed from Earth back to Venus, and then on to the planet Jupiter, finally arriving in Saturn orbit on July 1st, yes, Canada Day, back in 2004. And this was a very remarkable mission. Whichever way you want to cut it, Cassini operated for the better part of 13 years in flawless fashion, examining every aspect of the Saturnian system. By the way, I should also mention out, just for good measure, it slipped by an asteroid in the main asteroid belt. Where was it? I got its name here. 2685 Mrzursky, although it wasn't very close. It was a 1.6 million kilometer flyby, sort of like a bit of an afterthought. So, Cassini and its asteroid flyby, no great shakes. However, it did get to Saturn quite uneventfully in the grand scheme of things in 2004. It threw the Huygens probe overboard later that year, and Huygens descended to the surface of Titan. Really spectacular mission, Huygens. It only delivered about three and a half hours worth of data when all was said and done, but the imagery under a parachute canopy from Huygens as it drifted through the very thick atmosphere of Titan, examining shorelines, looking at riverbeds, looking at the lakes. There's even Lake Ontario on Titan. It rains methane, the whole 9 yards. It's the only other object in the solar system. Titan is the only other object in the solar system that has permanent liquid on its surface in the form of these lakes and seas. Now, that liquid is not water, it is liquid methane. It's minus 180 degrees Celsius, give or take, on the surface. But nonetheless, Huygens, courtesy Cassini, spectacular mission. Who can forget?
Absolutely.
Who can forget Enceladus? The little moon that who would have thought you would have been flying through geysers of water spouting out from the tiger stripes there. Cassini sent back imagery of the Saturnian ring system in unparalleled detail. The ringlets, all of the shepherding satellites, the extra rings that were much further out than the traditional A, B through F. Okay, the E and the G ring. Every aspect of the Cassini mission really was quite spectacular in its ability to improve our understanding of the Saturnian system. And that includes auroral activity at the North and South Pole. Right to the very end, Cassini was stunning. It flew through the ring plane as it headed for its last hurrah. Its last hurrah was September 15th, 2017. NASA flew Cassini into the atmosphere of Saturn at about 75,000 kilometers an hour, obviously to incinerate the vehicle to make sure that it could not accidentally land on Titan and potentially contaminate the Titanian system. But it flew into the atmosphere, delivering data back to Earth to the very last second. So the Cassini mission was a stunning success. It ran for over 20 years from launch in 97 through till its demise in 2017. It was 10 years in the making prior to that. So when you think about it, Cassini actually spanned about 30 years. Very, very successful. So hats off to it. Venus flyby on this date, June 24, 1999.
Well, yes, we can thank Venus in a little bit for this mission anyways.
Absolutely.
And it was, as you say, an absolutely amazing mission. And the images that came out of there, I believe that at some point they actually caught what they thought was an active moon or moonlet formation at some point. It was just, and of course, as you say, the lakes of Titan. And they found changes on those lakes, right? Between the, because they had radar images coming back from this mission where they actually could see. So it's not just that there's, liquid on this moon, it's actually changing over time. And I mean, this is a whole generation of astronomers wanting to build sailboats has came out of this.
Well, that's right. I mean, the European Space Agency is seriously contemplating a return mission. It might be in your active lifetime as an astronomer, Elena, but it certainly is going to be another 20 years or more before we see it. But the aim of the exercise is literally to drift around these lakes and be able to get a better understanding of how another ocean, another lake operates at completely different temperatures and a completely different type of atmosphere and so on. I think that'd be an absolutely stunning mission if we could get to it.
Oh, absolutely. And we already have a helicopter on Mars. Why not?
That's right. Exactly. Hey, if you can fly a helicopter on Mars, it must be child's play to do that on Titan. I mean, it's an atmosphere that's 60% thicker than Earth's. I mean, you could just about, rotate slowly on Titan and still be aloft.
Well, I'm convinced. If I was in charge of funding it, you'd be sold.
Thank you very much indeed. There was another image for Cassini, speaking about Titan, where they managed to have Cassini in the right place for it to sunlight to glint off one of the lakes, and Cassini picked up the reflection of the lake. Really neat little image. Marvelous piece of technology in that regard.
Oh, absolutely. And as you say, infinite amazing pictures. Just
correct. Quite correct. All right. Do you want to give us one more shout out?
Yeah, I think I'll go ahead and go back to 1983. It's been a little hopping around in time, but this is a pretty fun one. So on June 18th, 1983, we had astronaut Sally K. Ride become the first American woman in space. And this was a pretty big deal at the time when she launched with her 4 crewmates aboard the Space Shuttle Challenger. So this was mission little bit unfortunate that it did take 20 years, but so this, but it's still a really wonderful mission. And of course, this was the class of 1978 astronauts. She was the capsule communicator, or Capcom, I believe earlier on in the early 80s. And she became mission specialist on STS-7. So this was a really, really interesting point in history, I suppose, back in the 80s. I don't remember very much of it personally, but it's really fun to think about how all of this was going on, because of course they had the space shuttle at the time, and NASA astronaut selection was very, very, very rigorous. I mean, it still is. But with all of the private spaceflight and the opening up of spaceflight that we've seen just this last year, or year and a half, so many more people going up into space, and the tremendous difference between sort of this time and what we had before. It's really I don't know, a wonderful time in history. And it was a 6-day mission, I believe. So it was a complex shuttle mission, and they had some communications satellites. I think it was actually a Canada satellite, so Annex C3, Canada's Telsat satellite. So Canada gets a special connection to this one as well.
I did not know that.
Yeah, it's pretty fun. So if wherever we can, we like to point out the Canadian connection.
Absolutely.
And we had a robotic arm deploying the shuttle pallet satellite, and it was lots and lots of amazing photographs. Of course, they did have not a super long mission, so 6 days and some change maybe, but the ride's launch on STS-7 was almost exactly to the day of the 20th anniversary of the launch of Soviet cosmonaut Valentina Tereshkova. And it was really, really fun to, see all this, sort of recap when I was reading up about it earlier. Of course, Valentina Tereshkova was June 16th, 1963. So this is a little bit before. So actually, I suppose this is 2 This Week's in Histories in 1. And Tereshkova launched aboard Vostok 6 using the call sign Chaika, which I'm probably saying wrong, but it means seagull. And her mission was a part of a second group of flights launched by the Soviets, and she had I believe several orbits. She went around Earth 48 times over 3 days, and then made a successful parachute landing, which is very, very adventurous.
But standard for the Soviets back at that point in history.
Yes, exactly. For our I suppose modern standards, this would have been a very different type of launch than what you have seen recently with Blue Origin and SpaceX. And in their own ways, it was quite interesting to see this sort of two sort of trailblazers for space back in the 60s and the 80s, respectively. So June 18th, 1983, the Sally K. Ride with the Space Shuttle Challenger.
I'm going to also just put in a little bit of the politics here. That you're absolutely right. Valentina Tereshkova did fly in '63, but she was the only woman who flew from the Soviet space program until literally 3 months before Sally Ride flew. That was when the second woman in space flew, and that was Svetlana Savitskaya, if I'm pronouncing that even remotely closely. So the Soviets did like playing politics. Tereshkova flew in large measure because NASA had precluded women being eligible to fly, and we won't even talk about the Mercury 13 at this point in time because that would take up the rest of the show. But NASA literally wouldn't let women fly a space mission until the class of 78 and Sally Ride in 83. So they were behind the times, whichever way you want to cut it. But the Soviets flew Tereshkova literally just to rub NASA's nose in it, and then they too didn't fly another woman in space until Sally Ride was about to fly, and that's when Savitskaya flew. So there's a lot of politics that keeps cropping up in spaceflight history, unfortunately.
Yeah, well, and it is really too bad that it sort of took so long for it to open up there. And I'm hoping that one of the things we can look forward to with the new different types of ways to get into space is a little more access for more people, more equal access for more people.
And that certainly has been steadily becoming the case. Most of the astronaut teams that are now selected are very close to 50-50 men and women. The effort to try and ensure that various minorities are also selected, and I'm talking about NASA at this point in time. Canada still has a bit of a ways to go in terms of parity, but there are certainly efforts being made to get better balance for the various astronaut groups to better reflect, if you will, humanity as a whole.
Absolutely, and it is true that one of the people Sally Ride inspired was Mae Jemison, who has said that she was inspired by Sally Ride. She was chosen for NASA's astronaut program in 1987, and in 1992 she went on the Space Shuttle Endeavour, becoming the first Black woman in space. And just as a little call out, she's also on record as being a tremendous Star Trek fan, and was cited as sort of being also inspired by Nichelle Nichols from the original series, Lieutenant Uhura. So
there you go. Excellent.
It is getting, as you say, better. Each progressive sort of set of astronauts can inspire the next, and that's what you hope to see. Of course, Mae Jemison is very, very inspirational. So if you haven't read up on her spacewalk, definitely do.
Very good. Folks, you're listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory here at York University in Toronto, Ontario, Canada. Elena and myself, Paul, keeping you company this evening. By all means, point your favorite web browser to observatory.info.yorku.ca and join the online public viewing team for their commentary. I don't think there's any live imaging tonight. When I last looked outside, it was pretty cloudy, but they nonetheless will be available to answer questions, not to mention show up wonderful images from the past. Couple of items. We've got Teletube on Wednesday, correct, Elena?
Almost. Actually, we are doing an in-person atrium tour. So, as you mentioned before, the observatory proper is somewhat of a construction area still. There's a lot of electronics been pulled out of things, getting it plugged into other things. We don't want you getting electrocuted, so we are not opening up the observatory doors, but we have a lovely atrium location that's just over on the parking garage, just across from the Petrie Science and Engineering building. Now it's called the Arboretum Parking Garage, I believe.
Yep, or the William Small Center, whichever way you want to think of it. It's labeled both ways on the maps.
All you have to do is go up to the top floor, and you cannot miss us. The tickets you can get by going to our website and just clicking on them are free Eventbrite tickets, but please do get a ticket if you plan to go. If it's clear on Wednesday, we will be out there with all of our telescopes from 9:30 because, not to spoil our next news item, but there's a lot of daylight at the moment, so it doesn't actually get dark until quite late. So 9:30 to 10:30 in the evening, we will be doing an in-person atrium tour this Wednesday, this week, if it is clear. So if it is not raining like it is right now, then we will be out there. If it is raining, if it's very cloudy, please don't come out. We won't be able to open up.
Well, the good news about Wednesday, as far as the amount of darkness is concerned, it will be a few seconds longer in darkness on Wednesday than it is on Tuesday, because as you suggested, June 21, yes, that is tomorrow, at 5:14 Eastern Daylight Time, that's 9:14 Universal Time, summer arrives. Yes, indeed, spring is about to be in the history books, in the rearview mirror, people, and summer will have finally arrived. And so you can start your summer celebrations tomorrow. It'll run for 3 months, of course, until on or about September 21st, and that will be the equinox, the fall equinox. But yes, the summer solstice is on deck for tomorrow here in the Northern Hemisphere. My condolences to the folks in the Southern Hemisphere. It is your longest day of the year in terms of darkness, not in terms of sunlight. So yes, the depths of winter in Australia, although Australian winters are, yeah.
It's pretty mild.
Pretty tame, eh?
I mean, unless there are places that get cool, but I've never seen it lower than plus 10 Celsius.
In all the Australian capitals, that's pretty well the case. Canberra can get a touch chillier, but everywhere else, yeah, it's pretty mild stuff in Australia.
That is true. If you're in the guest house and bring a coat. Yes, exactly. But as you say, with all of that pesky sunlight, it will start to improve astronomically with slightly longer nights. So we have that to look forward to.
Absolutely. I'm one of the few people out there, and you're probably another one, that actually enjoys the long nights of November and December, because you can sort of be observing by 5:30 in the evening, get everything rock and roll, and you're home for dinner at 7:30, and you've got the entire night set up for observing.
Two words, programmable domes, right? I am so looking forward to this winter. We'll be able to write up our programs for observing, go ahead and check the observatory, and when they're all good to go, you let it just run all night. We'll have a weather station to close. It's going to be amazing. And so, yeah, those longer nights are really, I mean, I have to say there is something about being able to get out the barbecue for summer, but the long nights in winter, they absolutely win.
An observer's dream. I agree with you wholeheartedly. I've always enjoyed being in the dome 5:30 in the evening, and before the programmable domes, observe for 3-4 hours, and I'd still be home by 10 o'clock, and I will have a data set to work with. I mean, that was, as far as I was concerned, was gorgeous. It really was.
It still is.
Quite true. There's another little note here.
Yes.
Do you want to mention that?
Yes, we also actually should do a quick congratulations, because the other thing that's happening this summer for the first time ever, probably ever in Ontario, maybe ever in Canada, there's an astronomer in residence program with a provincial park. And that is our astronomer in residence program for the Allan Carswell Observatory with the Killarney Provincial Park. And I just wanted to give a little call out because we're welcoming our second astronomer in residence, Caroline El-Khoury from the University of Toronto. She starts today. So I would just want to say congratulations to her. She's out at that dark sky site, setting up the telescopes if it's not raining there. And we can look forward to some pictures, blog posts, and maybe even a live stream from her later on during the week. So huge congratulations to Caroline El-Khoury. And just as a reminder, as a totally fun extra thing to do, you can actually hop on to the observatory.info.yorku.ca, go to the Astronomer in Residence program and read the blog and see the images that they were able to get up at that dark sky location. We love talking about the importance of dark skies, but this is just super fun. So lots of more astronomer in residence updates coming as more people go up during weeks of the summer. So congratulations, Caroline, and looking forward to more of these.
Very good indeed. Yes, an excellent initiative and something that will really bring added astronomy value to Killarney Park. It was always a great spot to go to. Now you've got the added element, the added bonus, if you will, of somebody who actually can inform you about the night sky and help drive some of those wonderful astronomical telescopes around the sky. So, yeah, great initiative.
And we were talking about telescopes earlier, what you can do with small telescopes. Just as a little call out there, at Killarney Provincial Park, there is a small observatory which has been set up basically for this program by Bruce Waters, and it has a 10-inch and a 16-inch. So you will actually be able to do better than Messier.
Absolutely. 10-inch. Well, very nice indeed. Got to get out there. Add it to my list of things to do in the not too distant future.
We'll ask you next year.
Well, absolutely. In between teaching and traveling. Absolutely. Yeah. Okay, we've got a couple of news items we wanted to share. Do you want to do the first one?
Oh, actually, let's go for yours. I'm actually quite
fine.
keen to talk about the this really
James
interesting
Webb?
thing. Yes,
Sure.
exactly
Not
that
a problem
one.
there at all. We're getting very close to the first data release of the James Webb Space Telescope. Now, for those of you who have been living under a rock for the last 20 years, the JWST is the successor to the Hubble Space Telescope. And this is a telescope that's got a history, and boy, does it have a history. You're going to see all sorts of books written about this telescope, not just because of the wonderful astronomy that it is going to deliver to us all across the planet, but also because of the politics and the cost overruns and the delays. But we're not going to talk about any of that tonight. We're just going to talk about the fact that since December, it's launched, December 25th, great Christmas present, the telescope has been working its way through a series of calibrations. Well, of course, it had to unfurl itself in the first month, because it was packed into the nose cone of the Ariane 5 rocket. But after it managed to extricate itself out of its cocoon-type environment and deployed its 18 mirror segments, deployed its sunshade, because it doesn't want to look at the sun ever, 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 after it did all of that during the first month, and every astronomer on the planet was holding their breath or biting their nails to the quick, all of that went flawlessly. So 3 cheers to the planning and to the technical teams. But then the real work started with respect to focusing the telescope, making sure all those 18 mirrors were basically delivering light to the same point in the secondary system so that light could then be redirected into any of the three primary instruments. That was really quite the undertaking. The images that came back, the engineering images showing the real great focus that had been achieved, absolutely stunning. So everything was going along well. The sunshade was protecting the telescope. The telescope was plummeting down to about minus 225 degrees Celsius because this is primarily optimized telescope in the infrared. So you've got to keep it nice and cool, and it's got to be nice and stably cool. Everything was going along really well, preparing for that July 12th data release, and then wham, we got hit by a meteorite. Well, actually, I guess a meteor, because it didn't land on Earth, so it's not a meteorite. But it got hit by a meteor. In fact, the telescope system has been hit 4 times by meteors since its launch. Some of these are to be expected. I mean, we live in a pretty, shall I say, dirty, dusty environment. There's lots of this stuff flying around. If you're outside at night, for example, you are likely to pick up shooting stars cruising through our atmosphere, little pieces of debris that have been, in this instance, caught by the gravitational field of the Earth, pulled through the atmosphere at literally tens of kilometers a second, incinerating and burning up. Our atmosphere protects us.
Yeah. And there is a schedule of meteor showers to watch out for.
Oh, yes, that's true. But then there's the occasional rock that just comes through unannounced anyway.
So we I mean, and that's you always hear meteor showers. Go look outside. So next time you are out trying to catch a meteor shower, maybe spare a thought for the JWST.
That's right. It happened to be in the wrong place at the wrong time, but it had no choice. It's out at L2, so it's out there, and it's going to get hit. And NASA knew it was going to get hit. But the hit that took place in May of this year was a little bit bigger than was anticipated. Nothing to destroy the telescope or anything, but nonetheless, you've got these brand spanking new, pristine mirrors, and now they're being smacked by little pieces of debris. So, personally, I'm a little annoyed, but there's nothing you can do about it, okay? There's no force field a la Star Trek that is going to protect the telescope. Sorry. Allan, can you get on to that?
I would really love to. I have a feeling that the power required would increase the weight to the point of unlaunchability.
I thought dilithium crystals were not. Anyway, okay. Moving on. Okay, at any rate, one of the mirrors did get hit. And as you can well imagine, that is a little bit distressing. It certainly has caused a small amount of damage to that mirror, but not to the point where it has endangered the use of that mirror. And it certainly has not compromised in a significant way the overall imaging capability. It has degraded it a touch, but the mirror combination, the ensemble, had already been proven to be delivering far beyond specifications. That is to say, the resolving power of this telescope was beyond the engineering expectations. And so we've dragged that total quality back just a touch, but it is still above the pre-launch expectations. So yes, we've been hit. Yes, we've been hit several times, but it is not to be concerned about at this point in time. So NASA is still on track for the July 12th. They have tweaked that mirror, by the way. It did cause a little bit of misalignment. They have corrected that. The James Webb team was on it very, very quickly. And there is no expectation that this damage or damage in the future, as I said, we are going to be hit at the rate of a little divot every couple of months. That's just life in space. But as long as we don't get hit by a sizable fragment, as in, say, for example, a baseball, then the small little dings and divots here and there will likely be scattered across all of the mirrors. Each of the mirrors will be gently adjusted. All should be well. So mark your calendars, people. July 12th, that is the data release date for the first science images of the James Webb Space Telescope. Will be great.
Indeed, and I think mark your calendars twice if you need to. The initial images were so good. This is just super exciting. And you mentioned it is all the way out at L2, so of course it's all the way out there by itself. There's nothing else really close by to maybe I don't know, deflect with gravity or something. For example, if you were going around the moon, you might try to hide around the other side. But it's interesting, the Gaia probe is also out at L2, as I recall. And there's one other, I think there's 3 current probes in the same area. I wonder how often they're getting hit.
That's actually a very good question. I don't know. I think that was the location where Herschel was located as well, yeah. Gaia, as you indicated. And there was one other, but I can't remember its name just offhand. Of course,
Spectre.
Okay.
Yep.
Of course, the big difference between those scopes and James Webb is that James Webb has a slightly larger cross section. I mean, it's got 6.5 meter diameter, mirrors that are just sitting there waiting, inviting a micrometeorite impact.
Our big, beautiful, gigantic, shiny golden mirrors. Yeah. That's 6.5 meters. That's a good cross section.
It is, and as a consequence, as I said, we were fully expecting impacts, but most of the stuff in space is pretty small. I mean, space is big. Okay. There's a lot of sort of dusty debris, sand-like material that is flying around the place. And that was the sort of stuff that we were expecting James Webb to be hit by. And that's what it has been hit by 3 times. This one, and actually, I don't think I've actually seen an anticipated size, but the way they talk, I guess they're talking about, say, a centimeter-sized object. They are statistically going to happen on a certain frequency, and I think in the lifetime of the telescope, 5 years or so, they're expecting one of those to get hit. It's just unfortunate it happened within the first 6 months, and that rattles everybody. You think, oh my gosh, I got hit within the first 6 months. What's going to happen next? Will it be a baseball? Will it be the Blue Jays hitting it out of the park? I mean, I don't know.
We are, similar. I mean, it is a larger telescope, but Gaia, as I recall, is 4.6, almost 5 meters, right, in one dimension. So it could, I mean, and I haven't heard anything about it getting hit, so that'll be good for, that'll at least be good for James Webb to give us a little bit more confidence back.
Well, this is true. I mean, the other thing to think about James Webb, we've got the 6.5 meter diameter mirror plane, but think of the tennis court that's underneath it as well.
Yeah.
Okay, we are at the top of the hour, folks. You've been listening to York Universe, the weekly broadcast of astronomy and astrophysics out of the Allan Carswell Observatory. Elena and myself, Paul, been rattling around the universe here, hopefully keeping you entertained as well as educated and informed. By all means, please stay tuned for the rest of Science Night in Canada, Western World, Science for the People, Quirks and Quarks coming your way. Remember, summer tomorrow morning. Wake up for it. Well, maybe not, but when you get up for breakfast, it will be summer, and tune us in to Teletube on Wednesday. From myself, good night.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
AFM.